Welcome to VKS Coding. In this video, we'll talk about design a short URL. So basically, this is a high-level design we'll discuss for URL shortener. So let's first understand what is a URL shortener. So what URL shortener will does is, suppose client will give a long URL. Client is having a long URL, and it will give a to shortener URL service, right? URL shortener. Then it will return a short URL. Short URL, right? So this is the first task of this URL shortener, and the second task will be when the client will give a short URL, right? Short URL. Then this URL shortener service should return a long URL redirect. Long URL redirect status code, so that browser can automatically redirect to long URL. So this is the basically the service of URL shortener. So what is the idea behind it? Suppose you have a long URL and you wanted to share in Facebook, LinkedIn, WhatsApp. So it look very ugly, right? To length of very heavy characters. So we'll see in very details and example is also. So let's understand the problem and establish the design scope. And also we can ask the interviewer as well to give the example of the URL shortener, how it works and give some examples. So we'll see all these things in detail. So the next thing is let's understand the problem and design scope. So this is the long URL. If you see here, https www.systemdesigninterview.com q/sms system c logged in l equal to long. So this is the long URL, and when this URL is passed to the URL shortener service, this should return us the short URL, and this is the short URL https www.tinyurl.com. So this is the company domain, and this is the one ID. So this is the ID is generated for this URL. So when we pass this short URL, it will return as the long URL. So this is the so we can ask more question to the interviewer to get the design scope to limit it out to for system design. So what will be the traffic volume uh, to it will hit to the URL shortener service? So let's say interviewer will saying 100 million URLs per day, 100 million URL per day. And another question we can ask interviewer is also like how much short the URL should be. So this is the www.tinyurl.com. So this we cannot change it. We cannot do anything. The remaining thing, this is the length, right? It can exceed like A, B, C, D, something. It can be like that. So how much short? So we can ask the interviewer like how much short the URL should be. So and the interviewer also can say as much as short as possible, as short as possible. Means we have to see how much sort we can generate with the number of combinations, right? We have to support this 100 million user per day. So, and we can ask the again one more question to the interviewer is what is the character allowed in the shortener URL? So when we generate this URL, right, this ID, so what are the characters are allowed when we try to generate it? So that time they suppose interviewer is saying you can use numeric character, and you can use small alphabetical A to Z, and numeric 0 to 9 and capital A to Z. So these many characters and number only you can use to generate the short URL in the combination of number and characters. And one more question we can ask the interviewer is can the shortener URL can be deleted or updated? So for simplicity, let's assume a shortener URL cannot be deleted or updated. So cannot be deleted and updated. So this is our requirement for designing the short URL shortener. So let's proceed and So basically, we got the idea, right? So what will be the our first thing is long URL. Suppose we are getting for this, our service will return short URL, and when we pass the short URL to our service, it will return long URL, and browser will automatically redirect to the long URL. So basically, when we return the long URL, we'll send HTTP status code as well something, so the browser can understand and it will automatically redirect to the long URL. So this is the thing we have to do, and these are the requirements. So let's proceed, and for the back of envelope estimations for read write operation and the storage space. So let's move forward, and let's compute those things as well. So in the back of envelope estimation, what will be the write operations? Means how many URL to getting the URL to be short request we are getting. As the interviewer says, 100 million URL generated per day. So what will be the write operation per second? So this we have to compute it. So computing this one is very easy. We have to get the 100 million, and we have to divide by 24 hour into 60 minute into 60 second. So this will come approx to 1160 write per second. So we can round as well. There is no issue. We can say 1000 write per second. So similarly, we have to compute the read operation as well. So assume the ratio of the read operation to the write operation is to 10 is to 1. Means then when we have to compute the read operation per second, then it will be very easy, like how we have computed for the write operation per second. So similarly, we are going to compute is 11 into 60 is means 10 read operation and 1 write operation. So these many seconds for the write operation into 10. So these many read operation per second, read per second. And after that, we need to compute the storage requirement as well. So assume the URL shortener server will run for 10 years, and this means we have to support record for 10 years. So to support the how many records for 10 years? So suppose we have 100 million URL right per day. 100 million into 60 365 365 for a year, and it for 10 days. So it will come approx. This is the 30 and this is the million and three zeros. Then it will become 365 billion. So these many records we have to store it for 10 years. So to storing these many records for 10 years, how much storage space is required? So assume the average URL length is 100 byte. Then the storage requirement for 10 year what will be? 365 billion. 365 billion record, right? 365 billion record we need to store it, and each record having a 100 bytes, right? And it need to be stored for 10 years. So when we will compute this one, then it will come to 365 terabyte. So these many storage space will be needed when these 30 becomes right, three zeros, 2 and plus 130. When we can go to billion, to next is first is kind of a million, then billion, right, then trillion. So like this it is, and it if you map these things, it will come to TB, GB, and MB, like that it is. So I'll explain the backup envelope estimation in very detail how we compute these things. But here you understand one basic flow, like how we compute the read operation, write operation, and the storage space. So first is the write operation. 100 million user records are generated per day. So to compute per second, just divide it by 24 hour, 60 minute into 60 seconds. So these many 1160 write per second it will come. And we have assumed 10 is to 1 read operation. Then whatever the write operation is coming, just multiply with the 10, then you will get read per second. And the record, the storage space you wanted it. So we have assumed here it's for 10 years. And so basically 100 million URLs we need for 10 years, then just simply multiply with the 100 into 10 into 365. 365 is a 1 year, 10 year. So it will become a 365 billion. And here we are computing the actual storage space. So suppose one ID is taking 100 byte, then 100 byte for 10 year, it will become 360 billion record to a 365 terabyte. So these many storage space we needed. So I'll create one separate video to explain this in detail how to compute it. So let's proceed and see the API, how the API can be designed for this URL shortener. So API endpoint facilitates the communication between the client and the server and will design the API with the REST style. So first one is the URL shortener here. And to create a new URL shortener, to create a new short URL, client send a post request which contain one parameter and the original long URL. So this is the basically this is the post request here, and this is the API version 1 data shorten. And here in the payload we pass this is kind of a one string as a long URL attribute, and another string is the actual long URL we pass as a payload, and the response will be the shorter URL. So it will be like this www.tinyurl.com klmnop, something like this it will return. And the second option for the service will be URL redirecting. Suppose the get request will be coming as by passing this short URL, then the response will be the URL for HTTP redirection. So we'll see one request response flow, but here it will return a long URL with the HTTP redirection. So suppose it will return a HTTP status code. Status code is 301 for permanent redirection, and in the location it will return a location header as a long URL. Then the browser will automatically redirect to the long URL. So when we hit the get this short URL, in the response we will get the HTTP status code 301 and the long URL. So it will automatically redirect the browser to the long URL. So we'll see one request response flow to understand better. So let's proceed further. So here I have given one example for URL redirecting. Suppose we have this short URL tinyurl.com abcdklf. Suppose client make a get request to the TinyURL service, then the TinyURL service return the status code as 301, and it will return in a header as well the location of the long URL. Then the browser will automatically redirect to the long URL, and that suppose the long URL is this one facebook.com something something like dp and something. This link will be there. So what is this status code, HTTP status code 301? So basically 301 redirects the request URL permanently moved to the long URL, and since it is permanently redirected, the browser caches the response, and the subsequent response for the same URL will not be sent to the URL sorting service. Instead, the URL requests are redirected to the long URL server directly. So in case of 301 status code, and suppose we have made the request status code response as 302, in this case the redirect means the URL is temporarily moved to the long URL, meaning the subsequent request for the same URL will be sent to the URL shortening service first, and then the redirecting to the long URL server. So in this 301 is permanent. So only one request will come to the URL shortener service, and the later it will be cached in a browser. And in this case, every time it will hit to the URL shortener server. Right. So what are the benefits of each of them status code returning? So each redirection method has its pro and cons, and if the priority is to reduce the server load, then using the 301 direct makes sense. Only the first request to the same URL is sent to the URL shortening service. However, if the analytic is important, then 302 redirect is the better choice, and it can be track right click rate and the source of the click easier. So basically, this is for analytic purpose, and this is to reduce the load on the server. So each having the each own benefits. So as per our requirement, we have to return the status code for a redirection. So let's proceed and understand the data model, how we gonna store it, and how we gonna structure it. So data model is very simple. First one will be the ID, and that will be a primary key as well, and it will be kind of auto incremented. First, one more column will be for short URL, other one is for long URL. Basically, in high level design, everything is stored in a hash table. It is good starting point. However, this approach is not feasible for real world system as the memory resources are limited and expensive. And the better operation here is to use store the short and long URL mapping into relational DB. So we will go with relational DB. Relational DB. Now let's proceed and see. Let's deep dive on how we are generating this short URL. So URL shortening. So basics. This is the our core problem. How you are generating this short URL. So this is the our core problem that need to be answered here, and this is the more important for this interview question. So suppose a client send a URL, long URL, and suppose we use any hash function that will generate this code, right? This short URL code, and this is the our domain name. We cannot change it. So this is the ID only we can change it, and we have to generate this ID. This ID we have to generate. We have to generate for each long URL, and whenever the short URL they will send it, then we have to return the long URL with HTTP redirect, right? So how we gonna generate this ID? So this is the question. And suppose we use any hash function, then we have to answer it which hash function and how we gonna generate it. So let's proceed further and let's see how we gonna generate it. And one more question we have is what is the length of this character, right? This is right written KL5KJK something something. So what will be the length of this ID also? Because in the interviewer he said as much short that can be possible. So how we can compute and get to know to support 100 million record 100 million, right, URL to be shortened each day, how to support this, right? So we need to see how many characters we need it. So how to compute this? Let's proceed further and check this question to be answered, how we can answer this question as well. So basically to compute the hash value length, right? So how many, suppose this is the URL short URL tinyurl.com, and it is having abcl9. So how, what will be the character length, right, for generating this hash value? So to compute this, we have to get to know what are the characters we need, we can use it. So interviewer already said we can use the alphanumeric character, means alphabetical. Also we can use small and capital, small and the uppercase letter and the numeric letter. So numeric letter is 0 to 9, 10 can be used, and small letter 26 alphabetical, and capital also. So it will come to total 62. And suppose the n value is 1, then we can create only 62 combinations. 1 a b c d, like these many 62 combinations. And suppose n into 2, n to, if you make n to the power 2, it means we can create 3844, these many combinations, right? And if we keep the n value 3, means if we use the 3 character, then how many combination we can use? So these many, like it is coming around 23,834 number of combination we can generate. And if we give a n is to 4, coming around this value. And when n is to 5, then it is coming around this value. When n into 6, it is coming around this value. And when it's come to n is to 5, this is coming around this value. So this is when n is to 6, it is 56 billion. And when the n is to 7, this is kind of a 3.5 trillion number of combination can be generated. And how much we have to support? We have to support 365 billion records. So we have to generate these many number of unique ID. So if you use this n is to 6, means if you use a 6 character, right? If you use a 6 character length, then we can only support 56 billion, and that 56 billion is lesser than, right, 365 billion. It means it cannot fulfill our requirement. Then we have to go with the 7 character. When n equal to 7, we can generate 365 trillion. So 365 trillion is greater than 365 billion, means we will be left over with the our remaining IDs, but we can fulfill our requirements, right? So what will be the hash value length? So hash value length will be 7. So this is the answer for the hash value length. Value length. So hash value length will be 7, right? So how much short? So length means 7 character. 7 character short length we can generate the ID was 65 billion unique ID, right? That much we can support it. So the next question is how you will generate this hash value. Now we get to know we can generate the minimum length is 7, but how you generate the hash value. So now let's proceed further and check how that can be done. So how to generate the hash value? So there we have already we have a few algorithm and coding, and suppose we go via the hash function, then we have a MD5 algorithm and SHA-1 algorithm, and if we go with the encoding, then we have a base62 encoding. Let's discuss one by one. Suppose we use the MD5 hash algorithm, so it will generate a 128-bit unique value, and if we convert this to hexadecimal character, then it will generate a 32 hexadecimal character. So how it is generated? Suppose you have a 128 bit, right, and if you convert into the byte, then it will come into 16 byte, right? And one byte, if you see, one byte is having 843842 right? One byte will be used to generate two character, two hexadecimal character. One byte is used to generate two hexadecimal character. So we have a 16 byte, it means 16 into 2. 32 hexadecimal character will be generated. So similar to this MD5, SHA-1 also generate a 160 a bit. So we can generate only 40 hexadecimal character. It means the ID length is the 32 character, means A, B, C, D, E, F, K, L, 1, 2, 3. It will come around 30. So this much long it is there. But how much character we need? We need only 7 character. 1, 2, 3, 4, 5, 6, 7. So we need only this much character. But the length of the character is either a 32 or either a 42. If you go with the MD5 algorithm, or if you go with the shower. So what will be the problem of using these two algorithms? So if we trim down to 7 character, because we need only 7 character to generate the short URL, right? So the problem is we have to trim the extra character, right? Then we will able to generate the length of the 7 character. So in this case, what will happen? It will create a duplicates and a lot of collision as well. So it will create, so we cannot use a MD5 algorithm or SHA-1 to generate a hash value, because it will create a lot of duplicate and lot of collision. So now let's see base 62, how it is working and how we can use it. So in first we need to understand how the base 62 algorithm works. So suppose we have any decimal number is like 1,000 or anything. So what will be the for base 62 value, right? So if we convert 1,000 to a base 62 number, so we have to divide 1,000 to 62, right? So how it will go? So first we it whatever the remainder we have to keep it here as next to it, and how much it is getting divided we have to write it down. So if we divide with the 16, then 8 will be the remainder. If the and it is for 16, we have to find out the value for the mapping here. So suppose we need to use 0 to 9 as a number and A to Z as a character small and then bigger. So we will be mapping to each number as a 0 to 61, because we have only 62 characters to be used. So G is coming to 16. So like that, and when we map to the 16, so it will map to the G, and 8 is lesser than 62, so it cannot be mapped to any value, so 8 will be remain as it is. So it will be, the value will become G8. So unique ID is G8, right? So now what is the problem with the base 62? So we are able to generate the unique ID, right? And it is having lesser length as well compared to MD5 and SHA-1 algorithm. So let's discuss the problem with the base 62 and how we're going to solve it. So there will be two problem with the base 62, problem with base 62 algorithm, base 62 encoding, right? So first problem is we need a ID generator, right? We need a some ID, right? With that we will convert it to some value, right? Like how we have converted into the G8. So we need this ID. For this we will convert and create a unique value, right? Unique value length. And second one is the length could be different, right? Here it is generating only 2 character, but we need a 7 character. So how we gonna resolve two problem? So let's see one by one how we generate the unique ID first, and then we'll see how we solve the if the length is different. So first let's see how this number is getting generated, right? How we can generate this number. So let's see different approaches to generating our ID. So in the unique ID generator, the first approach could be the ticket server, and the idea is to use a centralized auto increment here in single server database. So here is really a single server, and the pros and cons will be it is easier to implement and it will work for a small to medium scale application. So this will be the pros, and the con is a single point of failure because once it will go down, everything will go down. A single ticket server means the if the server ticket server goes down, all the system that depend on it will also face the issue. And to avoid the single point of failure, we can set up the multiple ticket server. So we can set up one more ticket server here, right? Ticket server, and this will introduce the new challenges of data synchronization and a lot of other things. So now let's see the another approach, like how we can generate the unique ID with the different approach. The other approach will be the snowflake approach, and in this approach the ID will contain the first bit will be the sign bit, second one will be the timestamp, and the third bit will be the data center ID. We will be used for 5 bit, and 5 bit will be used for machine ID, 12 bit used for sequence number, and 41 bit for use for timestamp. So timestamp will be unique actually. And if we consider the number of combination to the power 5, it means 35 data center ID. And for each data center, 2 to the power 5 and 32 machine ID will be respectively generated. And 2 to the power 12 means 4096 combination of the sequences can be generated. And once this sequential will be reaches to 0, then automatically it will reset and it will start from 1. And it will be reset in every millisecond. So this is the second approach. Via Snowflake, we can generate the unique ID, right? So this is our second approach. So let's see the third approach, and third approach will be the zookeeper. Yeah, so the third approach will be the zookeeper, and if you know about the zookeeper is the distributed application, and it's a coordinator which coordinate reliably with each other and perform certain tasks, and it is managed by Apache Foundation. So basically what it does is, suppose we have these many combination of 3.5 trillion, right? These many five IDs we have. So it will define a range. Suppose this is a range 1, range 2, range 3, range 4, like that to range n. It will define it, and each range will have some series of numbers like 0 to 1 million, 1 million, 2 million, 2 million, 3 million, 3 million to 4 million. And we have a different tiny URL server 1, tiny URL server 2, tiny URL server 3. And each server will be assigned to range of its own. Like this tiny URL server will get range 1, tiny URL server 2 will get range 2, tiny URL server 3 will get range 3. And once it will able to consume all the uh, IDs, then it will assign the another range to from here is this list. So like this, the problem will be solved, and it will be well coordinated. And suppose if any server goes down, like this server goes down, right? So only one set of range is got unused, we have a lot of 3.5 trillion and we need only 365 billion of IDs. So it is okay if some of the range 1 million range is not used, because that can be trade off, because we have so many IDs to be consumed. So that can be easily trade off and interviewer will agree on that. So let's assume we will go with the zookeeper to generate the a unique ID, right? Now the what is the another problem? Another problem would be the length of the ID could be different, right? How we can solve that? So let's see further. So as I mentioned here also, the length could be different, right? So suppose we have base 62 and we have a ID 6, right? And it generate only the value as G, then how will fit into the 7 character, right? This is the first character, second character, third, fourth, 5, 6, 7, right? So how we gonna fill with the remaining character? So for this we'll do some padding, like double equal to will do, right? So like this will generate the ID. So the final ID will look like this: https www.tinyurl.com/g123423456 So this will be the ID, right? Short URL or a wrong URL. So this is the way uh, we'll fix the two problem. First problem with the how to generate the unique ID. So unique ID will be generated by zookeeper. Zookeeper will generate the unique ID, and for variable length we'll do padding. So all the problem will be solved, and after that once we have a ID we'll do 32-bit base 62 encoding on that ID to generate the short URL. And if the base 62 encoding length is less than 7, then we'll do padding, right? Otherwise we don't have to do padding. So we need to know how we generate the unique ID. We are going to generate the unique ID with the help of zookeeper, and whatever the ID is generated, so zookeeper, right? Zookeeper will generate the ID, and this ID will give it to base 62 encoding, right? And suppose whatever the value to generate, if it is less than 7, then we'll do padding, right? Otherwise we'll use as it is. As it is, that ID will use. So now let's see high level design of this a tiny URL service, URL shortener service, we can say that. So this is the client, and this is we have a load balancer, and this is we have a app server, this is the zookeeper, this is a cache, and this is the database, and database will be relational database. So suppose a client send a long URL, right? Long URL client is sending. Then first app server will go to the zookeeper. It will get the ID, and it will encode to base 62, and if it require, it will do padding. It will store into the database and store into the cache as well, and then it will return the response to the client. Then it will return short URL. And again, if the client is sending the same URL, then the app server will see if it is there in the cache, then it will return the short URL. Otherwise, it will query into the DB and it will return from there the short URL. So this is the high level design for the short URL. High level design for URL shortener service. Now let's see the flow chart in detail, how the IDs will be saved in the DB and how the IDs will look like and all. So I hope this is clear, because interviewer we wanted to know how you will generate the unique ID with a minimum length. So whatever the length we have computed, that is 7, then how you generate the ID, unique ID with length of 7. So that is the crux of this interview question. So if you figure it out, you are able to answer that question, then you are good with this system design. But this is the high level. These are the just explaining how we are saving it and returning the response and the status code and all. So let's see one flow chart as well. So this is the flow chart. Input will be the long URL, and the long URL is it is in DB. It will return the short URL, and if it is not in DB, then create a new ID with the help of Zookeeper, right? And then convert it to the base 62. If the length is less than 7, then we'll do padding, right? After that, we'll save the ID, short URL, long URL, everything. And this is the example also I have written. This is the long URL, right? So this is a long URL, http wikipedia org system design interval something I have written, and the unique ID for this it will be generated via Zookeeper as this one, and we'll convert this ID to a short URL using the base62 conversion to this one. If this value length is if this value length is less than 7, then we'll do padding, right? Otherwise, we'll save this ID into DB and return the short URL. And once the short URL get request will come, right? Then we'll return 301 status code plus long URL location, so that browser can automatically redirect, right? And 301 only one time it will hit to the our URL shortener service, and it will save into the browser cache, and the next time the same URL will come, so it will not hit into the our server. So this is all about the URL sorter service for the system design. So I hope I'm able to answer the all the questions like how to generate the IDs and how to encode it, different algorithm to use it, what the database can be used, how the high level design flow diagram, and the how to compute the length of the URL shortener. Thank you for watching my video, and please subscribe my channel to get to know more about the system design, high level and low level design for the interviews and interview tips and tricks.